Okay, so we will continue. We already completed till moment of inertia topic. So just try this question. I am sharing the screen now. So I have shared the screen. Check. A screen is visible to you.
The screen is visible, sir.
Okay. 1 minute. Okay. So now you can try this. We already discussed about moment of inertia. So now you can try this. Try this question. Suppose this is the axis of rotation and there is a rod which is inclined like this. This is the rod inclined at some angle theta with the axis inclined at some angle theta with the axis. Here this angle is theta which is given. So this angle is, let's say, theta, and mass of this rod is, let's say, m, and its length is, let's say, l. You have to find its moment of inertia about this axis. This is the axis. Do it. Try this. Is it visible to you, a screen?
Yes, sir, it is visible, sir.
Okay. Okay. Try this. Find the moment of inertia of this. So just use the most basic, you know, formula of the moment of inertia. How we calculate the moment of inertia of a system of particle by integration. So that start from that process, you will get it. If you have doubt, you can ask. Am I audible?
Sir, by applying instead of R, if you use R sin theta because it's considered small element.
Okay. Yeah. Yes. So then what is the final answer? Or you can just tell me the equation. Integration of what? Am I audible?
Those characters.
I'm audible or not?
You're audible, sir, clearly. Yes.
Okay. So what is the answer? You're doing integration of
So integration of m by L into R sin theta we can say. So if the particle or a small body with distance of R.
r sine theta or r sine theta square?
For sin theta
R sine theta only,
is
right?
integration from 0 to L.
Again, what is the expression?
The integral 0 to L
Okay.
m by L into R sin theta dr we can write or dx.
That is wrong. R sine theta square.
Sin theta
What is
plus
formula of moment of inertia for a particle?
mr square.
R square. So why you are not doing r sine theta square?
It's R square sin square.
Okay. Okay. So like this, you can integrate it within the proper limit 0 to L, and you will get it. Now the next thing is a radius of gyration. Okay. A radius of gyration is a very simple thing. Suppose that there is a body, and this body is not a particle, it is a body, and it can be any body, it can be disk, it can be a sphere, anything, any irregular body also. So for the calculation of moment of inertia, you can assume the whole body that its mass can be assumed to be concentrated at a distance equal to radius of gyration. Means if there is a rigid body, for example, this is a rigid body having some mass, let's say m, and let's say there is an axis, and the axis can pass through anywhere. So I'm saying that okay, this is the axis passing through the body. This is an axis passing through the body. The body will have some moment of inertia about this axis. Let's say that moment of inertia is I about this axis. Okay. Now, what I'm saying that you can replace this whole body just like a particle so that the moment of inertia remains exactly same. So when you replace this whole body by a particle such that its whole mass is concentrated, then at what distance you will keep this particle so that its moment of inertia remains exactly same as the first case, as the moment of inertia of the body. That distance is nothing but radius of gyration. Means if you replace this body by a point mass situated at a distance k, such that its moment of inertia of this particle comes exactly same as the moment of inertia of this body, okay, then that distance is nothing but radius of gyration. So here, now you can write this moment of inertia of this body as, okay. So in the second case, you can see we have replaced this by a particle. What is the formula of moment of inertia of a particle? mr square. So m, and what is perpendicular distance? That is radius of gyration. That is a distance. In place of r, you write k, mk square, where k is the radius of gyration of the body. Understood? Here you have any doubt?
Sir, no, no.
Okay. So let's go to the next. Okay, here you can see the example, like a body is there and that body is replaced by a point mass. How we can find the radius of gyration? You know that the body is made up of large number of particles. You know, if you add all the moment of inertia of all the particles, that becomes the total moment of inertia of the body. Okay, so total moment of inertia of the body, which is this numerator, is equal to m into k square. So from here you can find k is equal to under root of I by m. Okay, understood? Here you have any doubt?
Sir, no, no, sir.
Okay. So yes, last class we discussed about parallel axis perpendicular axis theorem, right?
Yes, sir, we complete, sir. Parallel
So
groups.
we already discussed parallel axis theorem, perpendicular axis theorem. Okay. So okay, so now you can try few questions. So you can start with this one. Try this. Try this one. Yeah, you can ask your doubt. Got the answer? Question is visible to you?
Sir, question is 1 minute.
Okay, try. You can use parallel axis theorem, perpendicular axis theorem. Also, you can use symmetry.
So then right uh,
Hmm.
so m by n so L 1 by pi plus r whole square.
Again.
So here I'm using perpendicular axis theorem.
Your voice is not clear, not audible.
So by using perpendicular axis theorem, so
Okay.
then IZ equals IX plus IY. So
Okay.
whenever we can say IZ as MR square.
Iz is mr square, correct?
And IX and IY will be about diameter. I think,
Yeah, it is half ring.
uh, so then from substituting the values you get about diameter MR square by 2 muscles.
Hmm. That,
And we can do
that will be
length of
for the full ring.
so the length of semicircle is pi r muscles.
Hmm.
From that if you substitute R equals to L by pi, we can get moment of variation of this semicircular ring about
Okay.
X and
Hmm. Okay. That is correct. Can do like that. Okay. Now you can try this question. Try this one. Do it fast. Just tell me the formula, what you will use. Process. You can tell me the process, just what you'll do.
So we will try to fundamental theory, but for penalties in parallel. At a distance L by B will be n square by 12 by n square by 4 meters.
Uh, yeah. So you will, which theorem you will use?
The parallel system.
Parallel axis theorem you are using. So ml square by 12 plus ml by 2
N
whole,
will be
right?
n L by 2 square.
And that
Each dot.
multiplied by 4.
Yes, sir, we get the
Multiplied
answer.
by 4.
Yes,
Because that is for 1. For 4, it will be just multiplied by
sir.
4. Okay, understood. So that is okay. Now you can try this one. Question is visible, right?
Yes, sir, question is
Hmm. So here you can imagine it like a book. Book having some length, having some width, having some thickness. This is a book. And the book is kept horizontal. That you have to understand. Book is horizontal. Axis is vertical, passing through the corner. Book is horizontal. Axis is vertical, passing through the corner, perpendicular to the plane of the book. Again, you can use the theorems, parallel axis, perpendicular axis. Are you getting any idea?
Getting to this pattern.
Okay. So you got it or you are doing? Yeah. So what is the answer?
But am I trying to explain this?
M by
N by 3 into a square plus b square.
m by 3 into a square plus b square. I think that should be correct. M by 3 a square plus b square. Correct. So you use perpendicular axis theorem, okay, and calculated about both the sides, right?
Yes, sir.
Okay, so like that, this can be done. Now, here in this type of question has also been asked many times. Now, here what you have to do is that there is a cut. Some part has been cut and removed from the body. So, in this case, what is the moment of inertia of the remaining part? So, what you can do is you can, and about the axis passing through here, O they are asking. Okay, that they can ask about any point. So now about this point, you will find the moment of inertia of the whole disk, and then you will subtract the moment of inertia of this part of the disk because this part has been cut and removed. So you must
Yeah.
try this question. Yeah.
Sir, how to locate where it will shift?
What?
The moment of emphasis towards the center or away from the both points.
No, I'm not understanding. You speak clearly and loudly. Take microphone closer to your mouth.
Um, so the moment of inertia will shift towards the center point, so
Will
point
not
two.
shift toward any point. Moment of inertia will not shift toward any point. Moment of inertia is not center of mass. It has nothing to do with what part is cut or added. It do not shift. It is always about the axis, and axis can be anywhere, as given in the question. It do not shift. See the axis. You have to find about this axis. It is not center of mass that it will shift this side, that side. It do not shift anywhere. You have to find moment of inertia about the axis, and the axis can be passing from anywhere. Whatever is given in the question about that axis, you have to find. Moment of inertia is always defined about the axis, and axis is given in the question. Axis do not shift anywhere by cutting or adding mass. Center of mass will shift. Axis will not shift. Axis has nothing to
So,
do with center of mass. Yeah.
so just center of mass in case of center of mass also these questions will be asked in this.
Yes.
Then
Yeah. So center of mass will shift, but that's a
it will
different
shift
thing.
towards the larger market and towards the
Yes. Not moment of inertia. Center of mass. So you have to find the moment of inertia of the remaining disk. What you will do, you will find moment of inertia of the whole disk, and then you will subtract the moment of inertia of the removed part.
both about this axis. Do it.
So generally, sir, if you get moment of inertia with some value, something like L seven ninety like that, means we can say this much times it is opposing the rotation motion. We can say.
Sorry.
So if we got moment of inertia some value, sir, then we can see that the body is opposing the rotation this many times. We can say. Now,
Not understanding. Again, speak clearly.
sir, if I say that the moment of inertia of any body is some x, some y,
Okay.
then we can say that the body is opposing rotational motion by times. We can say, sir. What is actual significance meaning? We can say, sir.
Again, you repeat the second part. After you said X, we will assume X and Y. After that, what you said?
So what is the significance meaning of this moment of inertia?
So moment of inertia just gives you
It is just a value, sir, number
idea
based
about
on
the, yeah. So it just gives you an idea about the resistance offered to stop a rotating body or to start a rotational motion. Like bigger moment of inertia means that its property to resist any change in a state of rest or a state of uniform rotation will be large. A smaller moment of inertia means you can easily rotate it about that axis, and if it is rotating, you can easily stop it, slow it down. But if suppose there are two bodies, both having same mass, suppose there are two bodies both having same mass.
yes, sir.
In the first case, the body is, you can take it as a disk of this size, smaller size. And second case, you can take it a very big disk, but the mass is same. Mass of both is exactly same. But in the second case, you will see it will be more difficult to rotate this body from rest, second body, because
Yes.
of its bigger moment of inertia. Although the mass is same. So it does not depend on mass only, it depends on the mass and the distribution of mass. In both the case, mass is m. Here also mass is m. Let's say 50 kg. And here also mass is 50 kg only. But now it is, the mass is distributed to a very large distance. This is, its radius is, let's say, 5 centimeter. Its radius is, let's say, 1 meter, 100 centimeter. So it is, its moment of inertia will be very large. So if both of them are at rest and you try to rotate them, bring them from rest to rotation, this one will oppose less, will offer less resistance to any change in its state. Whereas this one will have, will offer more resistance, more opposition to any change in its state of rest or uniform rotation. So it is that property which plays exactly the same role as the inertia plays in translational motion. Bigger the value of moment of inertia about an axis means about that axis, it offers more resistance to any body, offers more resistance to any change in its state of rest or uniform rotation. Only that you can say. You can again ask. Keep asking.
So means we can uh, we can say moment of inertia is a relative term. We can say sir.
Is
Is a relative term. So means when compared to another word only it has some meaning. Otherwise it is meaningless. We can say sir.
yeah means it's not like it has no meaning, but the thing is that yeah, in this way, if you have to understand, then definitely you'll have to compare it. So, for example, means every body will have some moment of inertia, and every body having mass will oppose any will oppose any change in its state of rest or uniform rotation. That property is moment of inertia. That's it. But then when you say that which has this has more moment of inertia, what does it mean having more moment of inertia? Then I will say more moment of inertia means more resistance. So then you need comparison. But moment of inertia in itself is simply, you can say it is just a property, you know, which opposes any change in its state of rest or uniform rotation. But then that for everything, when you compare, it's not only about moment of inertia. Same thing I can say for inertia also. A body having bigger mass, a bigger inertia. A smaller mass, smaller inertia. No mass, no inertia. So it is always about comparison, but it does not mean that they itself has no meaning. Everything is relative. Like,
Yes sir. Understood.
hmm, okay, try this question. So you understood the process here, what you will do for this question. Just explain the process, what you will do in this question.
Sir, they will find moment of inertia sir and apply for that parallax theorem and the perpendicular theorem we can do also.
Yeah, so for both, you will find the moment of inertia about the axis
Point
passing
four
through,
zero.
and then from the whole this moment of inertia, you will subtract this moment of inertia, right?
Yes sir.
But you must calculate it. You know, many times students make mistake, and this is a very popular question in JEE Advanced. Also, this type of question can definitely come. So you
Yes sir.
should solve this question. Definitely. Okay, so moment of inertia part is over, and from next class we will start the torque. So come prepared
Sir,
from next. Yeah.
I'm having some doubts in circular, but tomorrow can answer.
Okay. Yeah, you can ask your doubts tomorrow.
Yes sir.
Okay.
Thank you sir.
Okay then. Okay. Bye.